Perfect. So our company was founded. Was recently founded, as I can see, in 2009 by two dental technicians. Okay, by Mr. Brunato and Mrs. Elena Sacardo, his wife, both with pluriannual, multi-year experience as dental technicians. One specialized in removable processes, and the other one in fixed one. So both of them had the laboratory. They also they still have a family laboratory. But in 2009, they decided to found a commercial company because they wanted to protocolize all the steps inside of the dental laboratory, because it was a mess. It was confusion, chaos inside, and they wanted to protocolize every step of, and also to simplify the dental technician work.
Super.
We are in Vicenza. It's our city, we're a town. We are near Venice and Verona. This is our company. We also have a dental laboratory for training courses inside our company. And this is the group, the staff of Vert System, and this is the group of all cooperators of the company. We also have more than 20 dental technicians that cooperate with us to test products, to do training courses, all over Italy and also all around the world. We started like this in 2008, and after when we founded in 2009, the company, the first flask was like this, as you can see, and after we did the actualization, the up-to-date of the flasks, and these are the actual flask system that we have, the Furbo system. The advantage of the system is that we have a unique chassis, a unique base of the flask, as you can see, and it's interchangeable. You can only change the upper part to compose different types of flasks. For example, on the left part, you can see the removable flask, alubig, where you can do removable full denture, partial, skeletal. You can do a lot of also temporaries if you want. And we have the verticulator in the middle, and we have the Furbo composite flask at the right. In the last years, we've developed all the composite world. So we developed some other flasks. For example, the composite. Now we can also increase the height of the inside of the flask, because we do a lot of, for example, screw removable processes, screw retained implant processes. Okay, the hybrid processes, as we can say, and we work on master model, so we can put the master model inside of the flask without removing the model. So we need for sure a high height inside of the flask. After, in the next few years, we developed also the in these last years, we developed also the digital area with scanners. All our scanners has our Vert system engagement, and also the 3D printers of ours. As you can see, the Moonite XL and the Moonite, the small one. Do you hear me?
Yeah, sure.
Okay. So in these last years, we've been developing all the digital protocol. After we've been developing and finishing all the analog protocols, we've in the last 2 years we decided to also protocolize all the digital area, from the scanner to the 3D printing, to the post-curing, to the post-printing process, i.e. washing process and UV curing process, and after how to finish it, because there's a lot of company that show you how to do all the digital part, but can't show you how to finish it. And with the VERT system, we can do it, because it's all it can be integrated, and you also have always the same position. So for example, in our scanners we have the split of our flask, so I can do the scan of the model using the same position of the flask. So when I bring it to the flask, I will always have the same position, so I can respect the initial project. This is all for our workflow, as I can see from the analog, digital. Okay, we have, for example, the split cast, where we can do our dental cast for removable, and art pins for the fixed processes. This is our 2 machines of the post-printing process. We have the Moonwash. This is an electromagnetic machine that works with 3 intensity of washing process for no matter resins that we have in the market. You can wash every resin that we have in catalog. And after, we have also our UV curing unit, the Moonlight 3. Now this is the last one. It reaches 660 nanometers of light length. Okay, and we have 2 different programs inside. One for composites, for ours that we have all the pre-set programs, also 8 programs that you can customize it, and also all the 3D resins area, where you can find all the 3D resins that we've calibrated with our 3D printing machine. Yeah, and here you can see we have all the programs for the mineral, that is the composite. We have fast programs, as you can see, also for the quartz fiber bar, and 8 customized programs. So we are, as I can say, we are specialized in creating protocols, not only in doing products. All our products has to have a logic, a workflow behind it. So as you can see, all our models have the engagement of the VERT system has the same base for the movable processes, from the fixed, and also for the digital. You can see the engagement. The speedcast, now I show you a little protocol of the removable processes. So we pour here the stone, the plaster. We put here our impression, and we have our dental cast. And after, we go to do the workshop. We go to the articulator. As you can see, you have our split integrated in the base of the articulator. So you have always the same position. We do the workshop, as you can see, the setup of the teeth. And after, we start the registration. We don't use plaster, so our counter flask is in silicon. Okay, and our flasks are in aluminum, not in brass flasks. So the first step is putting this liquid, this fluid silicon that allows us to copy all the teeth detail, as you can see in the middle, and also to keep the teeth in position during the injection, because it reaches 88 short A, so it's really hard silicon. After we go, yes, you have a question?
One question about the articulator, that we can share the binet angle and the condylar angle for the articulator.
Yeah, of course. I can show you. Let me check if I can. Condylar parameter here are that you can adjust. You can see it. Yeah, of course. You can adjust it. So, second registration, we go to this one at the left. We do the registration with silicon Orange Plus. Orange Plus is precision silicon that contains substance that it's called hydroflow, that allows it to not absorb any liquid. So every part that will be replaced with acrylic resin has to be covered with the silicon. So we cover it, and this is the only silicon with the transparent silicon that we can put under pressure at 5 bars, okay, for 3-4 minutes, just to, in this case, it becomes more precise. After we complete our flask, we fill all the flask with easy putty or a putty press silicon, just to fill it. And we do also the entry hole and also the exit hole for the injection of the full denture. Our silicons remain stable for 2 years, and you can do till 6 polymerizations, hot curing polymerizations with our silicons. After we've been developing also other protocols. As you can see, we also have the stamping technique that we only, how can I say it? We enhance this technique because it's already existed, and with our reticulator, you can do this technique really, really fast and easily. This is after we also developed all the materials. We have, for example, all our resins are composite based. This is the monomassa, for example, a temporary for temporaries, but it's also certified in Class 2A. So it means that it's also definitive, permanent for permanent restorations. This is a acrylic resin with dentines, enamels, and intensive colors inside of one bottle. We have 4 colors that follows the Vita shade, as you can see. And we are using this. We sell a lot of this resin all over the world, and also in Italy, for immediate loading, for to the duplication of the full denture without using, for example, the acrylic teeth, or we do a lot of hybrid processes with these resins. This is an image, a picture of the monomassa characterized. And that's the result. It has an automatic translucency in the intercell part area, as you can see. because of its composition, chemical composition, and has a perfect adhesion, a chemical adhesion with a composite also, because it has a composite base. We also developed this year. We've been developed, and now we are ready with also our blanks, monomassa blanks. So the formula of this resin we brought into this blank. This is a 7-layer blank, and you can see the result. Do you hear me? Just to.
Yes, clear.
Okay, just checking. So this is the last product that we've developed, and this is also have a perfect adhesion with all the other materials that we have in our catalog. After we developed all the composite materials, so we have the flowable and paste composite, dentin, enamel, gum composites. We've been developing in the last month also other colors for the gum, more darker colors, and we also have all the range of characterization stains in composite and also liquids for characterization. This is, for example, an example of materials. As you can see, we can integrate that 3D printing, the monomassa, and the composite. This is a hybrid processes, for example. That's kind of workflow protocol we are doing a lot. We're doing a lot of training courses all around Europe for this kind of works. For example, in Portugal, in Spain, in Italy, we do a lot of this protocol. And our products allows you to do this kind of protocol easily and also faster, in a faster manner. This is, for example, monomassa, cut back on the closure part, injection of composite, and also after injection of our acrylic, pink acrylic resin, also that contains composite. Let me see if you can see the video. In the last year, we're also developing this kind of material, the quartz fiber bar. We started like this, and that's not the actual fiber bar that we have. This is the first version. As you can see, we have the model inside and also our workshop inside of the flask. After we pour the transparent silicone that we will put under pressure to have this glass effect, which allows us to inject after the composite or the monomassa. This is our polymerizer machine. We do some exit routes, ways for the material. We put the monomassa inside. We put a mineral primer, the bonding. We do the UV cure. We put this mono block inside of the counter flask. After we apply some composite around the abutments, we take this roll of fiber and composite, because the quartz fiber bar are composed by 30% of fiber, and the rest is composite, always based in quartz-based composite. we close all our flasks are closed by this torque wrench, calibrated with 8 newtons, so we always have the same position because of the base of our flask, and we always have the same closure of the flask. And that's the result. That's a little bit characterized, and this is the fiber. And that's the same process, but with a dentinal color. Okay, so here we have the A2 color instead of the gum of the pink. And that's the same process. We put this roll of fiber in composite. We put a little bit of always quartz-based composite inside to create the adhesion. We apply it very well. Also around the battlement, we close the flask, and we go down. We screw it, we block it till we will arrive to 0. That's a pressing technique. After we go to the UV curing process, and that's the result after opening. And that's I think the actual bar. As you can see, this bar you can see in the upper part in the left area, how it allows you to distribute all over this length all the charges, and these are the other ones are different materials that are too flexible and causes a how can I say it, can put in difficult the implant. As you can see, these are a little bit of technical information about the quartz bar. As you can see, the water absorption is less than 1%. It's an excellent thermal insulator, so it's not like the metal. So the patient doesn't feel this difference between hot and cold environment. This is the actual quartz fiber bar with some pins that we did in the last month. Now the bar is also it can be scanned. At the beginning, it was hard to scan it because it hadn't no content of barium. Now we put some barium powder inside it, so it's easy to also scan it and do a digital workflow. After we go to the scan, we do the project over it. We print them with this class 1 material. It means that it can stay in mouth for 30 days. In class 1 and A2 color, as you can see. We give it to the dentist, and the dentist do the essays in the mouth of the patient. The patient goes home, see if it's like if he or she likes it, if it's good. After he or she come back to the clinic, to the dental office, it goes to the laboratory, and this one of the 3D printing part we throw away, and we put into the flask and inject all in monomassa. And maybe we can do also a cutback of the teeth the closure part, and we do also an injection of composite. When it comes back to the laboratory, we close it. As you can see, we have the bar placed and also the prototype in class 1 material. With the wax, we close it. We do the gum. We go to the flask and we inject it. This is the process if you want to use the acrylic teeth, because, for example, we in verticism we don't use acrylic teeth anymore. We inject all in monomassa. But you can also do the setup of the teeth onto the quartz bar if you want. We always do this registration. As you can see, we remove the artificial gingiva, the gum with the silicone, and we do this registration with the orange silicone that has an elastic memory, because we want to copy all the detail under the processes, and also because that allows us to know where to do the bar, because it give us the volume and also the space. And this is the bar. This is this is the first one of the actual bar, because now all this material are contained by electro weld film. We print these arrows without 3D printing. We put it inside the battments. We fix them with some quartz-based composite, and they allows us to how can I say, to create holes into the bar. It's important to do this whilst it's how can I say, it's not hardened, because you can create some you can burn the quartz fiber bar after it hardened, because you can interrupt the fibers. I think it's a video. Yeah, that's a little bit of the process that we do for the quartz fiber bar. Now they have a little bit different design. We update the shape of these arrows. We put into the battments. We fix them with the quartz-based composite. We place the bar. As you can see, it's soft. It's a soft material. As you can see, we fix them with a cross fixing, and after we do the last UV curing, after we remove the arrows, we cut the excess with a ultra slim disc, and after with the burrs, we can also remove this how can I say, this mesh, that's net that covers the bar. With the primer, we fix it again into the model, and after we inject monomassa all over it, and it has a perfect adhesion, because it's all composite. The quartz fiber bar contains composite, also the monomassa, and it creates a one body working. So we go to the flask. We do the same registration that we saw before. We close the flask with the torque wrench dynamo block, and we inject monomassa. Here the result after we do a cutback also of the gum, and we put also the primer as always, we go to the flask again, we close the flask, and we inject the pink acrylic, always based composite resin. And that's the result. Here you have a full integrated body. You have in the middle here, we can see all the fibers of the quartz. You have the monomassa, you have the acrylic pink resin. It's all well integrated. You can't see any part that's not integrated. You can see any gray area. Okay, and the advantage of this material is also that you don't have the need to opacify it. It's not a metal, so you don't have to opacify the part. These are all the testing that we do of loading tests. You can see some data here of the strength, the resistancy of the material. And so loading is ISO machine to certificate the material, okay? And we do a test with 2.8 centimeters of distance between the two implants. And in here we have it's now own implant, its own some, not abutment, but dies with always the same height of 5 millimeters, and it reaches 1,786 Newton. It means 178 kilos per square millimeter. So it has a huge, for this kind of material, a great resistancy, strength, and has a perfect adhesion with our materials, our acrylic resins, our composites. That's an example of the integration of the materials, our monomassa, and also composites. Here's an example of the hybrid nylon 4 protocol. Here, this is the split cast, where you can see always the same engagement of the system. We go to scan, where we always have also the split of the system, so we can do work with the same position. We do the scan, we go to the 3D printing. Here we have two different types of workings. We print the infrastructure in castable resin, and the prototype with the class 1 material that we saw before. The dentist can do some adjusts, can functionalize it, as you can see. After we do a registration into the verticalator, because the verticalator allows you to also check the volume and spaces of the infrastructure. It has also other different uses, but in this case we use for it. So you can see we do a registration of the full anatomy, okay? And after we remove the full anatomy and we fixed the infrastructure, and we checked all the space and volume that we have for the monomassa before, after, when we have to inject it, or for the composite. So it's a check instrument, because it's important. Before, we lost a lot of time doing the CAD of the infrastructure, and we sent it to the laser sintering, and when it would come back, we have to, with the burrs, stay there 30 minutes. And now we do this check before sending it, and we don't have to retouch it. We don't have to stay there and retouch it with the burrs. This is our protocol, how to apply the opaque paste and also powder and liquid, the two different protocols for metal structures, of course, and how we put also the sprues of injection. The red ones are for the composite injection, and the blue are for the monomassa and the pink acrylic resin injection. With our system, we have also the possibility, for example, this is the flask. You can see the base with the model placed on it. And you can see that we also have some inclined planes that allows you to, for example, in removable processes, to bring back the model if the teeth touch the axis, the frontal axis, or for example, in hybrid processes, if you have a lot of undercuts, you can incline it just to remove some undercuts. It's logically you have to use it, this inclined plane. If you start using it, you also have to do the scan with the split with the 6 degrees inclined plane, because if you want to have always the same position, if you want to respect the initial project, you have always use it if you started using it. And here you can see the registration that we saw before with the orange plus silicon, the precision one that we put under pressure. And here you can see all the result of the registration, and where in this area gives us the information where we have to place, where we have to do the part. And we have all the volume for the acrylic resin before, after. So we close the flask as before. We pour the silicon, the 22 to shore A silicon. We put under pressure, as always. That's the result. It has to be like this. We inject monomassa. We do a cutback of the occlusal portion, okay? And that's the cutback that we need for the composite, okay? We want to give substance to the composite, a body to the composite. It's not a 1.5 cutback. It's an important cutback. So, for example, for the posterior teeth, we do a 1.5 millimeters, and for the anterior teeth, from 0.6 to 1.2 millimeters. That depends on the work that we have to do. So it's an important cutback. We also have all our stains. That's the composite stains. We also have the liquids like GC optic glaze, for example. We can characterize it. We put the primer, and after we inject the enamel. So the enamel goes down till the color, okay, till the marginal gingiva, and that's the cutback that we do also for the gum. We do a little bit of characterization with our composites. If you want to do it, we go to the flask again, and we inject with the same registration, with the same silicone registration. We inject the monomassa, the enamel, and also the pink acrylic resin, always composite based. We go to the UV curing machine, we put the right program, and that's the result. That's an interesting case that we have. We have this old full denture the patient. The patient only wanted to give a new face to it and to increase a little bit of the height of the teeth, the vertical dimension. As you can see, it was a brass. So we take, with the original processes, we take an impression, we do the cast with a split cast, we go to the articulator, as you can see, the same articulator that you saw before, and with the wax we adjust it. We're going to adjust the vertical dimension of the teeth, okay, and bring the anterior teeth back a little bit because it was too vestibularized. So we go to the same registration that we did before. With a fluid silicone, we go to apply it all over the teeth. Orange silicone registration, we put on the pressure, and after we complete the flask with the putty silicone, we close it with a torque wrench. It's always the same steps. Here we pour the monomassa just to show it that the translucency that it has in its incisal area. So we remove this block in monomassa and we finish it a little bit. We put it in, after doing the cutback of the gum, we put it inside again and we inject, of course, applying the acrylic primer. We apply, we inject the pink acrylic resin. After the dentist asked us to do the like a surgical guide. It's not computerized, okay? It's a normal surgical guide, just to give some ads, some help to the surgical to the dentist to put the implants. So the dentist do a surgical guide from it and take another impression with these processes, transparent processes. So here we have all the information that we need, the vertical dimension, the occlusion position of the teeth. We have also the position of the implants. And with this one, we do the definitive, the permanent, the model. We scan it, and from the removable full denture processes, we go to a fixed solution, okay? So we do the modulation of the teeth and the infrastructure. We print them. Here you can see. We do the same check that we did before. So we do occlusion and vertical dimension registration of the modulation of the teeth, of the anatomy. We remove it and we place the infrastructure just to check all the volume and space. So this is all the registration that you have of the inferior part of the hybrid process. So we go to the flask again. We place, now these sprues we are used to print them, not more in wax, because it was complicated to place them. So it's easier to print them and fix them with a little bit of wax. So these channel sprues are for the composite injection. After we place also the sprues for the monomassa, we pour the transparent silicone. We close the flask with a dynamo block torque wrench. When we go under pressure, we opacify logically the metal structure. Here you can see this is the silicone before the pressure, and that's the result before after. So we inject the monomassa. In this case, the MM2 monomassa, and that means A2, A3 Vita shade. We do a cutback of the closure part. This is a cutback that we did. We put the primer. We put some effects, so we characterize it a little bit, and after we inject the animal. And that's the last, UV curing process with the air barrier with gel. We put into our UV curing machine. As you can see, it has a huge capacity, so you can put all inside all the flask. Also, an articulator or a particulator, there's no problem of capacity, because one of the problems of these machines is that it's small, and that has a huge chamber inside of it. And that's the result. So we started with a full denture solution, and we brought it into a fixed implant solution. And that means having a protocol. So you know the advantages of your workflow of your products, and also the limits that it has. It is always reproducible, repeatable. It's versatile, so you can adjust it to your kind of working, and everybody can use it because it's really easy to use. And you can do also the integration between two of them, the analog and digital. That it's really important nowadays to do the integration between the two, analog and digital. This is a project that we're doing now. That's a green project. We went to plant some trees here near us because we had a hurricane that hit all this area, and we decided to make part of this cause to plant some trees. And that's a green environment project that we did. Okay, so as you know, we have also our Facebook, Instagram, and also YouTube channel where you can see all our tutorial videos, some smart tips where we explain in some seconds the using of some materials, and that's it. And that's a little bit of the philosophy of the vertex system and how it works. So if you have any questions.
Thank you very much for this amazing, innovative, it's very interesting information that you share with us. Thank you very much.
Thank you for the attention and the time.
Yes. I have some questions.
Yeah, of course.
One question is about the ceramic, how to apply the powder ceramic for transparent.
Yeah, if you have a little bit of time, I can show you a video.
Yes.
So you can. Okay. So in this case we use the verticulator.
In questo caso si utilizza il verticolatore, vertice furbo. In questo caso abbiamo una modellazione in cera, ma potrebbe essere un provvisorio funzionalizzato, potrebbe essere un ponte stampato, un prototipo, non ha importanza. Andiamo a regolare la dimensione verticale per risparmiare il silicone e applichiamo un materiale che si chiama white press, Sulla parte della modellazione avete visto che la prima parte l'abbiamo messa su un foglietto bianco perché è la parte più liquida, perché ha degli olli particolari all'interno. Una volta che abbiamo coperto la modellazione della parte occlusale, con l'Easy Putty andiamo a collegare il coperchio del verticolatore con la modellazione. Dividiamo anche qua i due siliconi e facciamo il collegamento. Aspettiamo l'indurimento dell'Easy Putty. E una volta che il silicone si è indurito, apriamo il tutto. Vedete che potete comodamente sfilare la mascherina nel verticolatore. Il coperchio ha dei reperi in modo da ritrovare sempre.
For the ceramic, you can do also this technique for the composite, but for the composite you can also go under the equator of the sieves. For the stamping technique of the ceramic, you can only go till the equator of the sieve, because it otherwise it would be impossible to remove the cover without broken the mass of ceramic.
Sempre nella stessa posizione. Rifiniamo il silicone.
We refinish it. We remove some undercaps.
Una volta che alzo il coperchio, avendo 3 aste rettificate, è molto importante che non ci siano dei sottosquadri.
It's important to not have any undercuts.
Nella cassetta noi applichiamo del lattice fluido, perché il lattice fluido una volta indurito fa circa 5 micron di spessore e fa sì che lì la ceramica non si attacchi. Prendiamo dell'olio di vaselina, andiamo a isolare bene con l'ergo brush il silicone e poi andiamo con l'aria a togliere l'eccesso, e a questo punto andiamo a impastare la ceramica. Può essere una ceramica in monomassa, non ha importanza la marca, noi abbiamo stampato tutte, potete fare solo dentina, poi fare il cutback e poi con la stessa mascherina stampare l'ismalto, dunque potete fare un po' come siete abituati. Andiamo a condensare bene la ceramica dentro la mascherina, andiamo a inserire con una spatolina la ceramica e poi la applichiamo sulla struttura. Lo split della vertice furbo fa sì in modo che il modello vada sempre nella stessa posizione, e una volta che ho chiuso il coperchio comincio a condensare, battendo diciamo così con un martelletto sul coperchio, e andiamo a asciugare l'eccesso di liquido di acqua sia nella parte palatale sia nella parte vestibolare. È molto importante che questa operazione venga fatta con cura, dunque vedete che noi la condensiamo spesso, e una volta fatto questo con un pennellino andiamo a rifinire l'eccesso di ceramica che si è formata all'esterno. E praticamente siamo pronti per alzare il coperchio. È importante fare questa operazione con il verticolatore, perché il verticolatore è l'unico strumento che ha delle aste rettificate. E voilà, rispettato il progetto iniziale.
And after we go all straight up.
Vado a completare la parte vestibolare, la parte palatale, se fosse dentina vado a fare un cutback, faccio la cottura e poi vado a mettere gli effetti, poi vado a stampare lo smalto. Visto che c'è spesso il dubbio da parte dei tecnici, ma se io metto le masse succede che queste praticamente si mescolano. Elena cosa fa in questo momento? Sta mettendo della ceramica colorata, anche qui la condensa, per farvi vedere che assolutamente le masse non si mescolano una con l'altra. Vedrete poi quando lei alzerà il coperchio. Una volta fatto questo, il procedimento è lo stesso che avete visto prima. Chiudiamo, ricordatevi sempre di condensare bene e di asciugare sempre bene l'eccesso di liquido che fuoriesce sia nella parte vestibolare e sia nella parte linguale. Accertatevi anche poi sempre che il coperchio vada perfettamente in battuta con gli spessori in acetalico. Anche qua siamo praticamente pronti nell'aprire il coperchio. Prendo il coperchio, faccio una leggera rotazione di stacco dalla struttura, apro e voilà, questa è la modellazione perfetta rispetto del progetto, le masse perfettamente divise una con l'altra.
That allows also to save time.